Hey there! No matter where we are, we're always surrounded by particles bouncing against surfaces. The collective force that these particles exert is called pressure.
Pretend this marshmallow is an astronaut and this plastic bag is his spacesuit. As I remove air from the outside of the chamber, the force of the air inside the bag pushes outward to fill the less pressurized chamber, much like in space. When the bag finally pops, the air that used to be pressing in on the astronaut now occupies much more space and the astronaut expands. Houston, we have a problem.
We tend to think about pressure as force over area, like pounds per square inch in this car tire. But what if we thought about things in terms of energy? If we take the equation we already have, force over area, and multiply it by distance over distance, then we get work over volume, or energy density.
Bernoulli's equation quantifies exactly how much energy a fluid has. A fluid has three types of energy. First is pressure. Second is kinetic. And third is potential. So we set up an experiment. We created a tube with three segments. The two outside segments are larger, with a smaller segment in the middle. As the fluid passes through the smallest segment, the velocity increases, and based on Bernoulli's equation, we can estimate that the pressure in the segment is going to decrease, as you can see as the manometer changes in height.
So we've learned that pressure can be represented as force or as energy, but we wanted to learn how pressure is used every day in the real world.
That's why we came here, to the Duke Barometric Chamber, where they use pressure in the latest medical treatments.
So my name is Eric Hextall. I'm the clinical lead here at the Duke Hyperbaric Center, and I'm going to explain a little bit about how the chamber works and a little bit about pressure. Divers don't breathe 100% O2. Most of the time they breathe compressed air. When a diver breathes compressed air under pressure, air being 78% nitrogen dissolves into the blood plasma. It goes everywhere, but nitrogen is biologically inert. Our bodies don't use it. So it gets dissolved in the plasma, the body tissues, and it stays there. When a diver comes up, they have to come up very slowly and carefully, otherwise that's decompression sickness or the bends. And so if a diver has the bends, we put him in that chamber. Our typical treatment depth is 33 feet of seawater, so we put patients at twice atmospheric pressure, give them 100% oxygen, and the gas fluid interface in the body is in the lungs. So you've got two layers of cells in between the gas in the lungs and the plasma in the bloodstream. And so it acts just like the CO2 on the surface of your soda, dissolves oxygen into the plasma, then it can go places where it wouldn't be able to go otherwise.
So, from the depths of our oceans to the vacuum of space, we're always under pressure.